eating?
I am eating.
Today we want to introduce about
Integration by part.
the formula for integration by part is integration u dv equals to uv minus integration v du. There are some rules to apply this formula. First, we should let u as the things that when we differentiate it, the power of it will decrease. For example, integration x ex dx. If we let u equals to ex and dv equals to x dx, differentiate u, du will equals to ex dx. Integrate dv, v will equal to x squared over 2. From the formula we know that it is equal to u v, which is x ex times x squared over 2 minus integration v du, which is x squared over 2 times ex dx. And from here we can change it to x squared ex over 2 minus x squared ex over 2 dx. From here we need to keep using the formula, and we will not be able to finish the integration because the power of x will become bigger and bigger. So from the rules I've mentioned just now, we should not let u equals to ex, but we should let u equals to x, because the power of x will decrease. So from this way to do the integration x ex, it is wrong. Okay, now let us try to let u equals to x. Let u equals to x, dv equals to ex dx. When we differentiate u, du equals to dx. When we integrate dv, v equals to ex. And from the formula we know that it is equal to u v, which is x ex, minus integration v du, which is ex dx. And from here we can get the final answer of this question, which is x ex minus integration of ex, which is ex, plus c. And this is the final answer for this question. Okay, here comes the second rule. We should substitute u as the things that we can differentiate and dv as the thing that we can integrate. For example, integration ln x dx. If we substitute u equals to dx and dv equals to ln x, we are not able to differentiate u and integrate dv. So in this question, if we substitute u equals to dx and dv equals to ln x, we are not able to solve this question. Okay, now let's try it another way round. Now we let u equals to ln x and dv equals to dx. We differentiate u, du will equals to 1 over x dx, and dv will integrate it will become v equals to x. From the formula we know that it is equal to uv, which is x ln x, minus integration v du, which is x times 1 over x dx. We can cancel the x here and it will become x ln x minus integration dx, which gives us the final answer of x ln x minus x plus c. And this is the answer for this question. So from this example, we know that what is the second rules mean.
Now we move to rules number 3. When we need to apply the formula 2 times or more than 2 times in a question, we cannot swap the substitution. And I want to show you if I swap the substitution, what will I get? For example, integration x2 ex dx. Let u equals to x squared and differentiate u, we will get 2x dx. And let dv equals to ex dx, and we will get v equals to ex. Then we apply the formula. We can get x squared ex minus integration ex 2x dx. Then is equal to x squared ex minus 2 integration ex x dx. And now we need to apply the formula again. And then we try to swap the substitution. Let u equals to ex and then differentiate u, we will get ex. dv equals to x dx, and integrate it, we will get v equals to x squared over 2. Then apply the formula again, we will get ex times x squared over 2 minus integration x squared over 2 times ex dx. Then is equal to x squared ex over 2 minus integration x squared ex over 2 dx. And now we substitute back this to the question. So it's equal to x squared ex minus 2 this x squared ex over 2 minus integration x squared ex over 2 dx. And then we cancel the 2. We will get x2 ex minus x squared ex minus integration x squared ex dx. Then is equal to x squared ex minus x squared ex plus integration x squared ex dx. And then we will get integration x squared ex dx. You can see that if you swap the substitution, you will get the original function in your answer. From this example, we can see that if we swap the substitution, we won't get the answer. So I would like to show you the correct way without swapping the substitution on the same question. So this is the question. As usual, let u equals to x squared, differentiate it, we will get 2x dx, and let dv equals to ex dx, then we will get v equals to ex. So apply the formula uv x squared ex minus integration v du. And then it's equal to x squared ex minus, take the 2 out, integration ex x dx. And this part we need to integrate again, but this time we substitute the same part as the first time. Write it again. Let u equals to x, then we'll get dx, and let dv equals to ex dx, integrate it, we will get v equals to ex. Then apply the formula again. uv is equal to x ex minus integration ex dx, then is equal to x ex minus ex. Then we substitute this back to the question. X squared x minus 2 bracket x ex minus ex. Minus plus ex, sorry, it's 2ex plus c. So this is the final answer from the example. We know that we can swap the substitution when we need to apply the formula 2 times or more than 2 times in a question. Next, we move to a specific example. Then the example is integration ex sine x. For this example, the both part of this question can be differentiate and integrate. Let's try this question. As usual, we let u equals to ex, then we will get du equals to ex dx, and let dv equals to sine x dx, then we'll get v equals to minus cos x. Then apply the formula is equal to uv ex bracket minus cos x bracket minus integration minus cos x ex dx. Then it can change to minus ex cos x plus integration cos x ex dx. From the third example I mentioned, we should keep using the same substitution, which is cos x x dx. Then we let u equals to ex, then we will get ex dx, and let dv equals to cos x dx, then we will get v equals to sine x. So apply the formula again. We will get ex sine x minus integration sine x ex dx. Then it is equal to ex sine x minus ex sine x dx. Then we substitute this back to here. So it's equal to minus ex cos x plus this ex sine x minus integration ex sine x dx. After we apply the formula for 2 times, we found that this part is same with the original function. So we can move this to the left side. So the left side becomes 2 integration ex sine x dx is equal to here minus ex cos x plus ex sine x. So these two can move to right hand side, so it here divide by 2. Plus c. So this is the final answer. Next, I want to prove that if we change the substitution another way around in this kind of question, we will still get the same answer. Let's try again. Okay, here is the question. Integration ex sine x. Okay, let u equals to sine x, so we will get du equals to cos x dx, and let dv equals to ex dx, then we will get v equals to ex. Then we substitute back the formula. uv ex sine x minus integration ex cos x dx. So this part we need to integrate again. Let u equal to cos x, so du is equals to minus sine x dx, and that let dv equals to ex dx, so we will get v equals to ex. Apply the formula, so it is equal to ex cos x minus ex bracket negative sine x dx, which is equal to ex cos x minus integration plus integration ex sine x dx. Then substitute this back to here, so it is equal to ex sine x minus bracket ex cos x plus integration ex sine x dx bracket, and then is equal to ex sine x minus ex cos x minus integration ex sine x dx. So this part is same with the original function, so we can move it to the left hand side. So the left hand side is equal to 2 integration ex sine x dx is going to ex sine x minus ex cos x, and this 2 move to left hand side, sorry, right hand side. So this is equal to ex sine x minus ex cos x over 2 plus c. So compare this answer with the previous answer we did just now. We should get the same answer. Therefore, we can substitute any part of the question to u or dv, as we will get the same answer in the end. And the most important thing is we cannot swap the substitution in the question, which I mentioned in the third rule.
Now, I want to talk about a method in integration by part called tabular integration. Let's see an example. Integration x squared ex dx. If we do this question in the original way, we need to do integration by part 2 times. And now let's try to do it in the original way. First, we let u equals to x squared, du equals to 2x dx, and we let dv equals to ex dx. Integration dv will get v equals to ex. And from the formula we know that this equals to uv, which is x squared ex, minus integration v du, which is 2x ex dx. Okay, from here we need to do the integration by part again, so we bring it down here and do it here again. Okay, first we let u equals to 2x and du equals to 2 dx, and dv equals to ex dx, and v will equals to ex. So from the formula we know that it is equal to uv minus integration v du, so it is equal to 2x ex minus integration ex times 2 dx, which is, at last, give us 2x ex minus 2 ex plus c. So we substitute this back to the original question, and we'll get x squared ex minus blanket 2x ex minus 2ex plus c. And from here we'll know the final answer is x squared ex minus 2x ex plus 2ex plus c plum, another c. Okay, so this is the final answer for this question. Okay, now let's try this question by using tabular integration. Okay, integration x squared ex dx. First, we need to separate it into two parts. First part is we should differentiate it, and the other part is we should integrate it. Okay, we let x in the part that we should differentiate it, and we should differentiate x squared until it becomes 0. First, we differentiate x squared. Differentiate x squared, we get 2x. And differentiate 2x, we get 2. And differentiate 2, we get 0. And we let ex in the integration part, so we get ex, and we integration ex, we get ex, and so on and so far. We get ex till the last. Okay, so the answer of the question will become this times the second, this times the second, this times the second, and from the first is the positive, and then negative, and then positive. So the answer of that is equals to x squared ex minus 2x ex plus 2ex plus c. And you can see that the answer of this is the same answer with the way we done it in the original way. X squared ex minus 2x ex plus 2ex plus c, which is the same with this. So tabular integration is suitable to use in some questions that we need to differentiate repeatedly, and integration integrates repeatedly. For example, if you get a question which the power of x is very big, like for example, integration x to the power of 5 sine x dx. You can use the tabular integration to solve this question easily in a short time. First, we separate it into two parts. We let x to the power of 5 as the differential part and sine x as the integration part. So we differentiate x to the power of 5 until it becomes 0. So 5x to the power of 4, 20x to the power of 3, 60x to the power of 2, 120x and 120 and 0. And we integrate sine x repeatedly. First, negative cos x, negative sine x, cos x, sine x, negative cos x, and negative sine x. And then the answer of this question is this times this, 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 and this times this. And this is the positive and negative and positive and negative and positive and negative. And the final answer is equals to negative x to the power of 5 cos x plus 5x to the power of 4 sine x plus 20 x to the power of 3 cos x minus 60 x squared sine x minus 120 x cos x plus 120 sine x plus c. Okay, this is the answer for this question, and it is the same with the way you done it. It is the same answer you done it with the original way, and this saves a lot of time for you to do this kind of question.